workshop. Okay. Today is the last day. We'll wind up at 5:30. Now, already we discussed in detail to large extent about all these tools. Today I'm going to introduce you to one more tool called CAS, C-A-S. Look at this. In View, click on View. There's something called CAS. CAS stands for Computer Algebra System. CAS stands for Computer Algebra System. It's a very beautiful tool. We'll try to explore that tool. Just click on that to get a tool. Now, for the time being, I'll just close this graphic. I don't want this graphic view. I'll just close it. So this is the CAS window, Computer Algebra System window. Now, what all I can do in this? Just watch this. I'll enter a number, say 1, 2, 4, 8. And I want to do prime factorization for this. Just look at this. There's something called factor here. Look at this. 15 is split into 3 into 5. So click on that. It will give you all prime factors of that. All prime factors of 1, 2, 4, 8. You try for some other number. Just try for number 24 and click on prime factors. This is the prime factor. I mean factors. Just try it. So it's not only factorizes numbers, it also factorizes polynomial. I'll just take a simple example of a polynomial. I'll take x cube. I'll take a cubic polynomial. X cube minus say 6x square plus 11x minus 6. This is a cubic polynomial. I want to find its factors. Just click on it. You will get all the factors. So you get x minus 3, x minus 2, x minus 1. The degree is 3, so you get 3 factors. You try for one more. You try for 2x square minus 7x plus 6. Type this 2x square minus 7x plus 6. Just click on factors. You'll get all the factors. Okay. So I dealt with factors of number, factors of polynomial. Now, polynomial, I want to solve it. I want to find the solution for the polynomial. Very simple. You just enter the polynomial. Let us take a 2x square minus 7x plus 6. Let me take that. This is a polynomial. Here I don't want to factorize, but I want to find the roots. So here you see there's something called x solve. Solve. Click that. You'll get all the roots. You get x is equal to 3 by 2, x is equal to 2. Very beautiful tool. You enter this polynomial and see whether you get the roots. X cube minus 6 x square plus 11x minus 6. Take x is equal to, solve it. You get all the roots. X is equal to, you let the degree be of anything. If it has a real root, it will solve it. Okay, I don't know whether it will solve complex root. I have not tried. Let me try it. Let me take x square. I think it should solve. X square plus x plus 1. I don't see any reason why it should not solve. So it doesn't solve. So for that you have to put some other condition. Okay, so it gives you a null set. One second, let me try once again. X square plus x plus 1. It doesn't solve. No, it doesn't solve. Okay. If you want to delete, you just enter like this and say delete. It will delete by itself, one by one. Okay, so we found how to factorize numbers, how to factorize polynomial, how to find roots of the polynomial. Correct? Now suppose I enter, say, x square. I want to find the value of x square when x is 5. So here, look at this tool, substitute. You see, in place of this tool, click on that. It will ask what you want to substitute. X you want to substitute it as what? Say, let us say I want to substitute it as 5. I enter number 5. That's okay. It will give you 25. So you can find value of an expression, value of a function. F of x is equal to x square. I want to find f of 5. It's possible. Let me take this expression, x cube plus sine of x. I want to differentiate. Go to this, press differentiate. It will give you the differential. X differentiation is 3x square. Sin x differentiation is cos x. You type any function, in matter of time it will differentiate. Let us try to integrate log x. It's integration by parts. It's a process. Log. The answer is x log x minus x. Let's see what happens. Log x. I want to integrate. See this tool. There's something called integrate. Click on that. It will integrate x log x minus x. So you can differentiate, you can integrate. Suppose I want to solve an inequality. Say 3x plus 2 less than less than 5. You want to solve. Say solve. Always go to solve. X is equal to. It will give you the roots. Suppose you want to solve 2x plus 5. 2x plus 5 less than or equal to. Put less than and then put an equal to sign. Less than or equal to, say, 3. I want to solve it. Yes, it's possible. See, please check I think something's wrong. Let me check. I typed it wrong. Less than or equal to, say, 5. So it will automatically give you the solution. I made a mistake. Just 1 second. 2x minus 2x plus 5 less than or equal to 6. X is equal to. So it will automatically solve. So here the solution is x less than or equal to half. Now you see there's a computer probability calculator. This is a normal distribution curve. Normal distribution curve is a bell-shaped curve where mean at this point, mean median mode coincide. Here the mean value is 0, standard deviation is 1. Suppose my mean is, say, 3 and my standard deviation is, say, 2.3. And I want to find area between 2 and 4. Between 2 and 4. It will give you the area. See, it will shade also. 2 to 4. Suppose you want to find the area from minus 2 to 2. It will give you the graph. Minus 2 to 2. See, minus 2 to 2. And it is not at the center because the mean is 3. Suppose I put the mean as 0, we get a perfect one. It will shift. Suppose you want to do it from 0 to 2. It will give you answer as 0.5 because total probability is 1. 0 to 5. I let it try. See, it's almost there. Almost 5. Almost half. Okay. So these are some of the application of CAS. What all I did here? Factorizing a number, factorizing a polynomial. Okay. I can solve a polynomial. You see, one by one we can check it. factorize the number, factorize the polynomial, solve the polynomial. I tried to solve a complex group, it didn't come. I think some adjustment has to be made, it will come, but now this is value of the function, this is derivative. Integrate any function, integration, linear enmity, and of course we can always explore probability distribution. We can calculate, this is a normal distribution because that is much easier to understand. That's why I took normal. You can explore anything you want. Okay, I just give you a couple of minutes. You take some time and explore this. If you're absolutely clear about it, if you have no questions, then I go to the next one. You have to only explore. That's it. There's nothing in it. Just explore it. For lower classes, you can even verify BODMAS rule, like a 2 plus 4 minus 1 by 2 multiplied by 6 plus 7 minus 3 plus 2 into 5. You put anything you want. I want to know what its value is. All that you need to do is equal to. It will give you the answer. As per BODMAS rule, it will calculate and give you the answer. It's another beautiful tool. So just take some time, just practice, just at least make a note of it so that you can do it later. So this is called CAS. It's Computer Algebraic System. Computer Algebraic System. Should I wait for some time or shall I continue? One of you can unmute maybe. Should I wait? Okay, let's continue. Now I'll go to, today we are going to concentrate on 3D graphics. Okay. So how do you go to 3D graphics? Very simple. Go to view, press 3D graphics. You'll get the 3D graphics. So the blue, green, and red line indicate the respective axis. And just like before, you can explore all possible tools here. You can explore all possible tools. Okay. Now, what am I going to do here first? The first thing I'm going to do here is I'm going to do a question on maxima minima. Okay. So what question am I going to do in maxima minima? First, I'm going to find the maximum volume of a cone, a cylinder, inscribed in a cone. This is what I'm going to do first. So I'm going to explore this. Maximum volume of a cylinder inscribed in a cone. I think something wrong with the text, so we'll check that later. We'll remove the latex, it will come. Okay, now I think it should come. I typed in latex, so that's it. So volume of a cylinder inscribed in a cone. This is a slightly difficult tool. Okay, you see whether you're able to follow. I'll try to go as slowly as possible. You see whether you're able to understand. First step will be, I'm going to construct a cone of radius 3 and height 3. I'm going to construct a cone of radius 3, height 3. Now, how do I do that? You see here, there's a cone tool. You see there's a cone. Okay, click on that. You just go over it, it will tell you to select 2 points. That is the apex. Okay. And then you have to enter the radius. So what is an apex? Very simple. The one which I'm clicking first, okay, that will be the base. That will be the circle. Okay. The second point will be the vertex point. So I'm clicking at 0 and I'm clicking at 3. It will ask for radius. So I entered 3. So I got a cylinder. I got a cone. Just have a look at it. Just it's very simple. Just see. I got a cone. You can just move around. This is a tool to move, rotate. You can do whatever you want with it. However you want to see, you can see it. Okay. So I have drawn a cone. Very simple. Go to this tool, click on the cone. After clicking on the cone, first you click the base, click the origin, and then number 3, you get the cone. If you click 3 first and then origin next, you'll get a inverted cone. Okay. Now, I need my 2D window. Now I'm going to create a slider. I'm going to create a slider. Where is the slider? This is a slider. Now, how am I going to create a slider? The slider, I will call it as R. This R stands for the radius of the cylinder which I'm going to generate. Okay, radius of the cylinder. So it cannot exceed the radius of the cone, correct? I will put it from 0. I got a slider. I have created a slider for R. R is from 0 to 3. You can just check it once. R is from 0 to 3. I just created only a slider. That's all. Where R is the height of the cylinder. Where R is the height of the cylinder which I'm going to generate. Now I want to create H. What will be my H? My H, I'm going to define it as 3 minus R. 3 minus R. I'm going to define H as 3 minus R. Because when I inscribe a cylinder inside a cone, my height cannot exceed 3. Okay, it cannot exceed 3. It has to be less than 3 and it has to be positive. So it is 3 minus R. Press enter. So now I have prepared everything. Once again, I'll repeat. First, I created a cone. After creating a cone, I created a slider called R, which varies from 0 to 3, where R stands for the radius of the cylinder. Then I create a height, which is the height of the cylinder, which is 3 minus R. Everything has a logic. I am not simply choosing these values. You have to think and do it. R is from 0 to 3 because you know the cylinder that you inscribe cannot exceed the radius of the cone. And the height of the cylinder cannot be more than the height of the cone. It has to be less than that. Okay, so that is why it is 3 minus R. Now what I'm going to do, I'm going to choose a point D. See, capital D equal to, see how I choose, 0, 0, H. 0, 0, H. See where it comes. See, it is here. I just move R, then you can see H. Can you see? So this is H point. See, it will not go beyond this. It will be one. It will go only from this vertex to the base. Nothing more than that because it is 3 minus R. So it's a point on Z axis. Correct. So let me stop it here. So this is D. Now what I have to do? I have to construct a cylinder. Now how do I construct a cylinder? Click on the 3D window. Click on the 3D window. Go to this. Select cylinder. Select cylinder. After selecting cylinder, let us see what I should do. Select 2 points, then the radius. I have to select 2 points. So what I do, I choose one point as D. First I choose D. Then the other point, I choose it as A. That will ask for radius. Correct? So I will enter the radius as R, because R is the radius of the cylinder. Now press OK. Now you got a cylinder inside. Now I will slightly change these colors so that you are able to see things clearly. Color. Let me make it yellow. I'll make it right, and I'll make it very light in color, so that you can see that one. Okay. Now you can see for yourself that when I move this, you get a cylinder inscribed in a cone. You get a cylinder inscribed in a cone. Look at this. This G stands for the volume. Okay. Let's look at this. This B stands for the volume of the cone. It stands for the volume of the cone. This G stands for the volume of the cylinder. Just have a look at it. Very beautiful. Now, how do I know this is maxima or minimum? That's another question. So for that, I go to view and I select graphics 2. I need one more window. I choose graphics 2. You see, there's one more graphics window has come. I'll just move this slightly this side. So I need space. I move this slightly this side. So I got a second graphics window. Now I plot a point P equal to what? I should find P as radius versus volume. Your volume is G plus G. Finished. You got the point P. Now where is the point P? It's around 11, right? So this is only 8. So I have to change the scale. So I just go on this. I have already told you how to do it. Just pull it down. You can see the point. Now go on that point. Go on the point. Right click and put trace. Now go on the slider and animate. Now you'll see what you get. You will get a beautiful maxima curve. You see, you get a beautiful maxima curve. And this is the point. See, this is the maxima. Look at that. It's a beautiful maxima curve. So this is a simple application of maxima minima used in GeoGebra. Well, you need to really think and do this thing. It's not very complicated, but you have to bring in maths into it. And then, of course, you have to use the software. So I'll repeat once again the process so that in case you have a doubt, you can clarify. First of all, create a cone. Create a cone of radius 3 and height 3. Create a cone of radius 3 and height 3. Second step, create a slider R. Here, small r stands for radius of the cylinder. And the slider varies from 0 to R. Because you know very well that the cylinder cannot exceed the base of the cone. So the base of the cone radius is 3. So you cannot have more than 3. Okay? If you want, you can try it and see. This is how you should explore. You put some values. You put a value more than 3 and see. It will become very funny. Now let's animate. It will make no sense. It should not make sense. Let's see. Maybe because of my h it will work. I don't know. Let's see. See, it makes no sense. It goes out of range. That's because you have chosen things which makes no sense. Okay, so don't do that. So stop. So bring it back to. This is how we explore and see what. This is not just some gimmicks. There is a lot of mathematics. You have to think and do it. How do I know I have to select a slider of radius 3, not exceeding 3? If you think, I'm sure you all will get it. 0 to 3. And height, why should I take it as 3 minus r? Because the height, here I have taken the height of the cylinder as cone as 3. So definitely my height cannot exceed that. Okay. Then you can take a point D, that is 0, 0, h. Take a point D, 0, 0, h. Then draw a cylinder on AD of radius r. Then plot the points. You can try this later with radius 3 and height something else, not 3. You can take something else. Then in that case, your h will, suppose you take the height of the cone as say 7. Then what will be your h? 7 minus r. Very simple. Correct? So suitably you have to adjust. Any questions on this? Can I go to the next one? Or you want me to repeat the process once again? Anyone? If you tell me, I'll do it. If you don't say anything, then I'll go to the next one. Is it clear? Or if you think I'm going fast, you please let me know. Hello? Anyone? Is it okay? Okay. Online class கொஞ்சம் better போல. Yes. Okay, now I'll go to the next problem. Once again, I'll do one more question on maxima minima for you. Here the question will be very simple question. Already you know these questions from class 12th. It is like a constructor sphere. I mean, you want to find the maximum cone that can be inscribed in a sphere. Maximum cone that can be inscribed in a sphere. I just want to try this problem. Okay, I'll just make it a little bigger. So I want to find maximum cone that can be inscribed in a sphere. Now, how do I do that? The first step is I want to construct a sphere of radius 3. First of all, I want to construct a sphere of radius 3. How do I construct a sphere of radius 3? You see, here it is. You have sphere through a point, sphere with center and radius. So I'll choose the second one. So I will click on 0, 3. 0, 0, 3. I click, it will ask for radius. Enter radius 3. You will get a sphere. You can even click it at origin. I don't have an issue. Okay. I'll repeat this process. One second. Sorry. Graphics window. Graphics window. Sphere with center and radius. So I'll just go on. Maybe this time I'll try it with origin. Okay. Origin, radius 3. You'll get a sphere. So it doesn't matter where you click. Okay. But I prefer to do it at this point. So I'll choose that. Radius 3. Finished. So this is a sphere of radius 3. Now I'm going to make a slider. Remember, you're going to put a cone inside. Okay, you're going to put a cone inside. So I'm going to make a slider. So your slider should not exceed what? So let me call the slider as A. It should be from 0 to 6. It has to be 0 to 6. It has to be the diameter of the sphere. 0 to 6. So I've created a slider from 0 to 6. Okay, because my radius is 3. If my radius is 4, I'll choose 0 to 8. That modification you have to do. That is why you have to understand this, then it is easy. Now what I do, I want to mark this topmost point. What will be the topmost point? Let me call it B. I don't know what my algebra will is. One second. Delete this. Rename this to A. Now I'll choose B, which will be 0, 0, 6. Syntax errors. What is the mistake? B equal to I have to put. Then only I get the point. I got the point B. See, where is the point B? B is at the topmost. Okay. Now I'm going to create a point C equal to 0, 0, 6 minus A. 0, 0, 6 minus A. Let me move that A, then you can see the point. Let me make it a little lighter. Now see whether you're able to see the point. See that? This is C point. It cannot go beyond this. So it will 6 minus A. 6 minus A. Okay, now I'm going to construct the cone. Now how do I construct the cone? So click on the window, select cone. I have selected the cone. Okay. And I want the circle inside, not there. Okay. So first I click on point C. So first I click on point C. Where is point C? Here it is point C. Then I click on point B. Then it will ask for radius. Radius is very simple because it is once again, I'll come to that. I'll come to this calculation later. Let me first find the radius. Radius is equal to SQRT, square root of BC into 6 minus BC. This is from Pythagoras theorem you'll get. Okay. So this is your radius. My radius is square root of BC into 6 minus BC. I think if you do the diagram in your book and do the calculation, you will see the radius is this because they have already done this in maxima minima. It should not be difficult. So I have calculated the radius. Now I'm going to make the cone. How do I make the cone? Click on C. Click on C. Click on B. It will ask for radius. So I will type R. So you can see a very beautiful a cone coming inside. Now you just move the slider and see. See the slider, it moves. Slider. So this is a cone that is inscribed in a sphere. It's not easy, it's difficult, but if you practice, I'm sure you'll get it. This one. And you see here D. D stands for, actually it is the surface, it's the volume, okay? Or you can calculate the volume and see, it's not a big thing. Now go to view, select graphics tool, and type point P. Point P equal to the slider A, comma, that volume D. Automatically you'll see this point. Now here you see these 38 point something. Here the scale is very small, so change the scale. Go on that. Well, you will definitely see the point. See, it's there. Now right click on that point, apply the trace. Now animate this, and you will see a maxima curve. You see, this is a maximum. The shape of the curve is a mountain, so it's a maximum. And this is the point. Actually, I have made an error here. I have plotted for surface area. That is why it's like that. If I calculate volume, I'll get it perfect. Okay. So that is why you see some funny things. Not exactly like that. So if I want, I'll calculate the volume. VOL equal to, what is the volume of let me just try once again. 1 second. I think I took the surface area. It has to be B. I'm sorry, it has to be B. So the point P must be, this is surface area, this is B. B is the volume. Now I think it should be perfect. Let's trace this. Come on. Animate. That trace. Just a second. There's some error in this. Trace. Image. Here it is here in this one. Just 1 second. Let me just type it in this one. I will type, I'll take the graphics 2 window, and I will say P equal to A comma B. A comma B. Where is the point? I'll type it once again. P equal to A comma B. I got it. Now right click on it and trace it. Now animate this, it should work definitely. You get a maximum. Okay. So once again, let me just repeat the process. Construct a sphere of radius r. Construct a sphere of radius r. Here the radius I took it as 3. Then make a slider from 0 to 6. Because the radius is 3, the slider should be the diameter, 0 to 6. Now choose a point B right at the top, that is 0, 0, 6. Then choose a point on the height, that is 0, 0, 6 minus a. Then calculate the radius. So your radius was square root of BC into 6 minus BC. Then plot the point. Okay. So this is how you get this curve. Okay, the third one which I want to do is the conic section. Okay, how do I get the conic section? That is even a little bit more difficult. Let us try and see how much ever is possible. We will do it. See whether you are able to get it, because it's a little difficult. These things are a little difficult. Okay. Okay. Okay, I'm going to make a conic section.
Hello.
Yes. Okay, how am I going to do the conic section? Just to follow the steps, because this is slightly complicated. So if you, I will wait. I will pause after every step. So maybe you can make a note, or you can try whatever you want. First, I want to create a cone. So select the cone. I want my circle here. So at 3 and at before that, let me create a slider. I want to create a slider for radius. So let me create a slider. If you want to create a slider, you need other 2D graphics. So I'll create a slider. And this is radius of the cone. Okay. So this will be, say, from 0 to 5, whatever you want. It's a slider. Okay. Now I'm going to create a cone. Click on the cone. First you click on the cone. Click at 3. Click at origin. It will ask for radius. You type R. It will give you the cone. So you can vary this sense. So you get a nice cone depending on what radius it is. Now I want to draw an inverted cone. Now how do I do that? So I select the cone. I want the circle here, right? So it's click at -3, 0 and at origin. It will ask for radius, type R. So you get an inverted cone. So first you make a note of that. So I first create an upward cone and a downward cone. How do I create an upward cone? If you want the circle up, first you click that point, then the vertex. For the downward cone, first click -3, 0, then origin. You get the cone. Change the radius and see. It's very lovely. You can change the color. I don't like this color, so let me make it some wonderful yellow. And so I already created that color. Same color. So I have created the cone. Just move and see. Move the cone and see. It's wonderful. Okay, this is done. Now the next part is very interesting. I'm going to create a slider. Without slider, nothing works. This time you don't have to tell me, at least you tell yourself what should be the answer. Okay. I can create a slider called N, and what will be the range? What will be the range? What should be the range at least? So the range should be the total height of the double cone, correct? Total height. So it is from -3 to +3. So if you make a cone at -2, 0 and 2, 0, make it -2 and 2. Yes, okay. Now just move it and see. Then only you will understand what it is. This is you have created a slider. You have created a slider. Because I'm going to move around this point. Okay. Okay. Now what I do, I create a point. Now I'm going to draw a point. Okay. First I take a point D. You can call it any alphabet you want. I call it D equal to 0, 0, n. So I got D. Let's move it and see. Can you see? D moves along this. It moves along this. Okay. Okay. I have chosen D. I have created a point D. Point D. Let it be. Now, two other points. However, where am I going to choose? I'm going to choose one on this surface. See this? If you go near the surface, this mouse will get stuck to that surface. Choose that. Click. You have chosen 2 points, wherever you want. So first what I did, I created 2 double cone and I created a slider from -3 to +3. From -3 to +3. And I chose a point D, that is 0, 0, n. 0, 0, n. Then I chose 2 points on the surface, on the slant height of the cone. After that, what do I do? Click on the 3D window and go to construct a plane. See, I require 3 points to construct the plane. I require 3 points to construct a plane. I have 3 points. What are they? 1 point. Yeah, 1 point is this. Hold on a second. 1 point is this. The other point is the D. And the third point is this. So you get a plane. You get a plane passing through this. So you can just move around and see. And see from the top, you can see the parabola. Can you see the parabola? From the top, you can see the parabola. Anyway, I don't like this color. I'll make it a little better. We'll make it pink. Okay. So I'm sure now you should be able to see it even more better. Can you see the parabola inside? You see there's a parabola inside. Can you see this parabola? Okay. This section of a cone. This is a section of a cone. The plane is cutting through the cone. Again, see, there's a lot of mathematics involved. That is why it's so beautiful. First of all, the two points of the plane is on the surface of the cone. The 2 points is on the surface, and the third point is on the height of this cone. Okay, so what I'm doing, I'm just only changing. Look at this. See what I'm doing. I'm only changing the different positions on the height, and I will rotate it and show you, so you'll see better. From the top, you see what is happening. Look at it. Circle. You see this ellipse. ellipse, parabola, and of course, you see on the other side hyperbola. So you see the conic section. So you can do it by yourself. You can show it in your class. It's wonderful. See this? It's great. Now, this is not the end of it. I'm going to do something else. I want to see the intersection of the two surfaces. This is called intersection of the two surfaces. See this? Intersection of two surfaces. So through this, you are also getting exposed to all the tools. So I click on intersection of two surfaces, go inside, and I just keep moving inside. When I move inside, you see it gets darkened. You see, this is the intersection of two surfaces. See, can you see the intersection of two surfaces? Now you can see a parabola. That's nice. Now, right click on it. There's something called create 2D view. Create 2D view. Right click on that. Create 2D view. Click that. So you can see the 2D view of this. This is not clear. Once again, let me just do it properly. To review of it. It's not coming. So you got the 2D view of it. You got the parabola. Cross section of the cone and the plane. This is a parabola. How wonderful it is. Now what do you do? Just move this. See where it intersects both the surface. Let's see where it intersects both the surface. To come down, if you see, if I move this slightly, now you see the plane cuts both the planes, or both the cones. The plane cuts both the cones. So that point I want to choose. So I click here, go to the intersection of two surfaces. See this? It gets darkened. That is the intersection of two surfaces. And you can see here the parabola. This is a hyperbola, intersection of two, the upper part and the lower part. Can you see this? It's nice. Now keep moving, keep moving. You can see this is parabola. Parabola becomes ellipse. Ellipse becomes circle. See? This. So this is a very simple application. So it's a difficult process. You have to understand the process. But if you try it, you'll get it. Once again, I'll repeat the steps for you. First of all, you create two cones, one at 0, 0, 3 and origin, other one at -0, 0, -3 and origin. That way you get both the cones. Then you create a slider. The slider should be from -3 to 3. The slider should be from, it should exhaust the total height, -3 to 3. Then choose a point 0, 0, n, that slider, 0, 0, n. That will give you a point on this vertex, on this line, this height. Then choose 2 points on the 2 surfaces of the cone, and using this property, plane passes 3 points, will automatically get the plane. Once you get the plane, you keep moving around. You just move the slider. You can see different cross section. You can see here also you see different cross sections. See, this is ellipse, ellipse, circle, parabola, and of course hyperbola. One part of hyperbola is here, the other part is on the other side of the cone. And you can always right click on it. There's something called 3D view. Click on it, you'll get the 2D view of it. As simple as that. So try it and see. It's very, very, very easy. So you can try it later. All these are, and it is very difficult to do 3D all of a sudden like that. See, until unless you practice, you explore, you may not be able to get it. So it will take some time, but at least I'm exposing you that you can do these things in GeoGebra. You can do any question on maxima minima in GeoGebra. You can do any question on conic section in GeoGebra. It's possible. Okay, now I'll go to the next one. Next 12th question. Planes and whatever, planes and straight lines. Okay, we'll see how to do that. First, I will go to the 3D window. Okay. Now, what question I'm going to do? I'll type. First, I'll type the question. So here also, I'm going to teach you something how to type how to type. Click this and select latex format. I'm sure some of you are familiar with latex. Okay, so select latex format. Okay, so I want to find image. I want to find image of what? Image 3. Image of this point in this line. What line? So go to symbol. Go to symbol. Go to latex. Okay. Go to latex. There's something called roots and fraction. Click that. So it will give you this alphabets A, B. Typing is not easy. So I want to type X. I just will show 1. Okay, X by 1. So I'll make capital X. So it will be small x by 1. Small x by 1. Go to this, type this. In place of A, you type small x. In place of B, you type 1. So you get x by 1 equal to, again, go to latex, fraction. You can do so many things in that. I'm just showing you one part of it. In place of A, you type, say, y minus 1. And the B will be 2. In normal typing, you can't get this in GeoGebra. So you have to type only in latex format. The other one will be, again, go to latex. At least I don't know. This is what I know. This is Z minus 2 followed by, in place of B, I'll put 3. I get this question. I want to find image of this point in this line. So how do I do that? It's very, very simple. Now, how do I type this line? First of all, capital X. This is the syntax. Okay, it should be capital X. You don't make it small. Capital X equal to. Where does this line pass through? It passes through the point 0, 1, 2. Correct? It passes through 0, 1, 2. So put that in bracket. 0, 1, 2 plus t times lambda or t, whatever you call it, t times. So t times, what is the DRS of this line? 1, 2, 3. 1, 2, 3. R1 vector plus lambda times n vector. I put the line. R vector equal to R1 vector plus lambda times n vector. Let's take the graph algebra window and see. See, this is the equation. So you can just rotate and see. It looks like it was passing through origin. It is not passing through origin. That is the beauty of 3D. See this. This is 3D. You can move around and see what is happening in 3D. You see it? Okay. This is equal to point plus t times this. Capital X is equal to point plus t times this. Now, how to find the image? So, very simple. Mark the point P equal to 1, 6, 3. 1, 6, 3. Okay, so you get the point. So you can't see it clearly. So if you can't see, move it and see. You see, it's very clear now. Different from different position. That's why 3D you can't take anything for granted. I want to find the image. How do you find the image? Go to this tool. Reflect about a line. Reflect about a line. Click on that. Point. Click on the line. You get the image. You can't see it, but now you can see. Can you see it? So this is the image. Let me zoom out a bit so that now I think you should be able to see things better. This is the image. And you can see 1, 0, 7. If you know this is a very famous question in NCERT book. Answer is 1, 0, 7. How to find foot of the perpendicular? Go to this tool, midpoint. Click this, you get the midpoint. That is the foot of the perpendicular. 1, 3, 5. So you can do straight lines in space using GeoGebra. This is one simple question. Again, I'll repeat. First, you type the question. That is the most important thing. Here, how do I type this question? Capital X is equal to point first. Point is 0, 1, 2 plus t times. What is the DRS? 1, 2, 3. Press enter, you get the line. After that, you know how to choose the point. From day one, we have been talking about choosing points. So choose the point. Reflect it about the line. Reflect it about the line. That will give you the image. You can do it in a very complicated way also. If you don't like to do this way, I'll do it in another way. First of all, I'll draw a perpendicular. Like this. Then I will find the intersection of these two. There are many ways to do. I find the intersection of these two. I found. Then I find the reflection of the point about this. The reflection of a point about this point. Click, you get the point. So there's many ways to do it. This is one of the simplest way to do. That's all. Use the tool and get it. I hope that is clear. Now I'll go to the next question. Next question is I want to find shortest distance between two lines, between two skew lines. Okay, between two skew lines. In case if you have a paper, you write the equation so you know what I'm typing. It will be x minus 4 by 1, y plus 1 by 2 equal to z by minus 3. X minus 4 by 1, y plus 1 by 2 equal to z by minus 3. The second line will be x minus 1 by 2, equal to y plus 1 by 4 equal to z minus 2 by minus 5. So I'm going to show it's a skew line. You know what a skew line is? Two lines which are not parallel and which do not intersect. And I'm going to also find the shortest distance between them. Okay. Actually, I have already found the shortest distance. The shortest distance using the formula, I get the answer is 6 by root 5. Okay. 6 by root 5. We'll find out what 6 by root 5 is. Okay. Whether we get 6 by root 5 or not. Okay. First of all, I will type the equations. Okay. Now here, I have already done one way, that is capital X way. Okay. So you know it. So you can try that at home later. I will also teach you another way to do it. Okay. I will also teach you another way to do it. So what is the other way? Let me take the point P equal to, this is a point, okay, this is a point P equal to 4 comma minus 1 comma 0. This is point P. And point Q, what is point Q? Point Q equal to 1 comma minus 1 comma 2. These are the 2 points through which those 2 lines are passing through. The first line passes through 4 minus 1 0. Second line passes through 1 minus 1 and 2. I am also giving you another way to draw the line. That's all. Okay, another way. So I have drawn P and Q. Now the 1, 2, minus 3 are DRs. They are vectors. Correct. Now how do I introduce vectors in 3D? Small letter. Don't forget small letter equal to, small letter equal to, what are the DRs? 1 comma 2 comma minus 3. Press enter, you get the vector. That is the vector. It is actually I vector. See, you can see clearly the vector sign. I vector plus 2j minus 3k. Now I want to create one more vector. How do you create the vector? V equal to, how do you create that vector? V equal to, it's small letter. If you put capital letter, it will become point. If you put small letter, it will be a vector. 2 comma 4 comma minus 5. I got 2 vectors. Now I want to draw the line. Okay. For the time being, I'll hide all this because I want to hide. I don't want some things. So how do I write the line? Very simple. Capital X equal to P plus P times P plus P times U. See that? It passes through the line. Beautiful. X equal to P plus T times U. This is another way of drawing the equation of line. I already told you one way how you can draw a line. This is the second way. Now you can try the next line. Here also don't put capital Y, put capital X only. Now that is the format for a straight line. Capital X equal to, here capital X means X comma Y comma Z. Okay, that's the meaning. Capital X is equal to, obviously it will be Q plus you put some other alphabet K times B. Lovely. For a common man, it looks like a parallel line. It looks like a parallel line, okay. But they are not parallel. They are skew lines. You can see for yourself. If you look at it like this, it looks like they intersect, but they don't intersect. So these are called skew lines. They are not parallel, but they will never ever intersect. They will never intersect. Can you see? They will never intersect. Okay. This is how you draw 2 lines. I'm sure you know how to do it. So I have introduced you to how to draw straight lines in 3D in 2 ways. One is the normal coordinate way. The other one is the vector way. Now I'm going to find the shortest distance. Now how do I find shortest distance? You should know the formula. Here I am using the formula R2 minus R1 dot N1 cross N2 by modulus N1 cross N2. Okay. So I'm going to use that formula. Okay. Why I am introducing that formula is I'm going to teach you how to find cross product. Very simple. How to do cross product in GeoGebra. Very, very simple. All that I need to do is I have to type cross. Okay. Cross. What is my N1 and N2? U and V are my N1 and N2. Cross bracket U comma V. That's all. You get the cross product. If you don't trust me, you try it and see. N1 cross N2 will be this. N1 cross N2 will be that, guaranteed. Okay. Now I want to find R2 minus R1, whatever alphabet you have learned, or I don't know. Difference of these 2 points. I want to find difference of these 2 points. So I will call that as a new vector. Say R1. Okay, R1 equal to, what is R1 equal to? 4 minus 1, 3. Then minus 1 minus of minus 1, 0, DRS. Okay, 0, and then minus 2. I hope you understand what I'm saying. R2 minus R1. R1 vector is R2 minus R1. I have created that. Now, what is shortest distance formula? R2 minus R1 dot N1 cross N2. Now, how to do dot product? Type dot. Automatically, it will ask for 2 vectors. Dot product of what? R2 minus R1. That is R1. What's the next one? W. I got the dot product. R2 minus R1 dot N1 cross N2 divided by modulus of N1 cross N2. How do you find modulus? ABS of W. I got it. Now, what is shortest distance? Shortest distance is R2 minus R1 divided by dot N1 cross N2. What is R2 minus R1? It will be 6. It will be A divided by B. So this is the answer. 2.68 is the answer. I got the answer as 6 by root 5. If you use the calculator and see, the answer will be 2.68. Here, that answer is not important for us. What I wanted to introduce you to is, how do I represent a vector? Very simple, small letter equal to, type the IJK coordinate. And I also told you how to find cross product. How to find cross product? Cross, write the points, finished. Cross product. Cross product of U comma V, U, V, that's all. Now, how to find modulus of a cross product? Absolute modulus of that. Dot product is dot vector, finished. So you get the shortest distance between 2 skew lines. Shortest distance between 2 skew lines. I hope this is clear. I will do one more for you. I will also find for you shortest distance between parallel lines. Okay. Let me give you 2 parallel lines. One line is x is equal to 1, 2, 3 plus t times say 2, 3, 4. I got a wonderful line. I'm going to draw another line which is parallel. Okay, so capital X is equal to 2, 4, 5 plus some alphabet, whatever you like, k times. Here it is 4, 6, 8. So you can see the DRS are proportional, so they have to be parallel. So whether they are parallel or not, we'll just move around and see. See, they are perfectly parallel. See, they are parallel. They will not intersect. I want to find the shortest distance. One way is you can use the formula. What is the formula? Formula is R2 minus R1 cross U by modulus U. You can use that formula, but there is a very simple way to do. Just draw a perpendicular and measure the distance. Finished. You see? Take a line, take a perpendicular, click on this line. Choose a point first. Okay, you need to choose a point and choose a perpendicular tool. Click on the line and click on the point. Okay, sometimes they are very funny. Let me see now. Some strange reason it's not working. Supposed to come perpendicular point. Okay, very exciting. Last one. Okay, I don't know why it is not working. I don't have an answer. Oh, it is working. I'm not able to see it. Okay, no issues. We'll try to find it. First of all, I want to find R2 minus R1. What is R2 minus R1? I call it as a vector. Okay, A, small letter A equal to, what is R2 minus R1? 2 minus 1, 1. 4 minus 2, 2. And 5 minus 3, 2. So I got that. This is R2 minus R1. Now what is the DRS? U equal to, this is the DRS. U, or I can say N equal to. N equal to, what is the vector? You can choose one of them. 2, 3, 4. 2, 3, 4. I got two vectors. Now what is the formula? The first thing will be modulus of A cross, this is A, right? A cross N. First you find A cross N. Cross bracket A, N. Alphabet na kanittu. Rename A then. Okay. Cross A, N. So that is cross product of A, and I want to find modulus of that. So I take A, B, S absolute of U. So that is my numerator. Absolute once again. B equal to ABS of U. I got the numerator. Denominator is absolute of the DRS. What is the DRS? DRS is the M. Now what is the shortest distance? Shortest distance is B divided by D. This is the shortest distance. And I got the answer as some root 5 by root 29. I think it is this one. Just check it out and get it. So this is how you find shortest distance between skew lines and shortest distance between parallel lines. Okay. Yesterday when I tried, I do something is wrong. I was able to draw a perpendicular, take this point and measure this length. It worked out very well. Today it's not coming. Now one more thing before we stop, I will tell you is you can also do it for a plane. I have done enough questions on plane, so you should be able to do it. Now last one which I want to tell you is differential equation. I don't need this window for that. We want only the differential window, 2D window. Now, this is a command. How to solve differential equation? Let us take a very simple question. dy by dx is equal to y square minus x square by 2xy. dy by dx is equal to y square minus x square by 2xy. It's a homogeneous differential equation. How do I solve it? Very simple. All that you need to do is type solve. Automatically it will ask solve ODE. ODE means ordinary differential equation. check the first one. Ordinary differential equation, type the function. Now what is the function? Bracket y square, it will be in small letters, I'm sorry, y square minus x square, y square minus x square, divided by bracket 2 into x into y. Solve differential equation. One second, let me see whether the brackets are correct. Solve y square minus. I think everything is done. Press enter. If the input something is wrong, y square minus x square divided by 2 into x into y. It open. This will be solve differential equation. Solve differential equation minus of x square minus y square divided by 2 into x into y. I got the differential equation. I solved it. It's a circle. It's a homogeneous equation. It's a circle. Now this is the arbitrary constant. Look at the arbitrary constant. If I move the arbitrary constant, I get family of circles, family of semicircle. See this. So you can demonstrate very easily what a general solution of a differential equation is. It represents family of circles. Now how do I find a particular solution? For that also you have to solve ordinary differential equation and point it. Now here what I do, minus of x square minus y square divided by 2 into x into y. And what is the point? Let me give some condition. Say 1, 1. I think some I typed capital Y, yeah. Is common, it's going to be 2x. 2x. I don't know some reason. You know why it is became capital. So we got it now. See this? This one is a particular solution. One member of the family. So if I move this, you see one of the member of the family will coincide. That is called particular solution. Whereas all these are general solutions. These are all general solution, and this is one particular member of the family, which is called particular solution. So these are the things that you can do. You can do a lot of other things. You can solve partial differential equation. You can do hell a lot of things using these tools. Okay? This is what I wanted to say. If you have, I have 5 minutes left. If you have any questions to ask, you can ask. Otherwise, thank you for joining the workshop. I hope it was a good experience for you. I enjoyed it. I hope you too. Thank you. If you have any questions, you can ask me. Otherwise, you can leave. Thank you. Any questions? Okay, then have a nice day. See you. Thank you. Thank you. Thank you very much.